Good day. This video will be covering the topic exponential equations. This is a continuation of a series of indices. Please, there are two previous videos before this. I'll advise if you're new, please go back and watch those videos. You'll be in the link in the description below. Now for an introduction, I'm going to give about 3 tips that will aid in solving exponential equations. Tip number 1. If you're given an exponential equation like this, 2 index reciprocal of x equals 16. If you can, write them in the same basis. In previous lessons, we recognize this to be the base and the power or index or exponent to be this. Now, what we're going to try and do is rewrite 16 to be the same base as 2 if it is possible, which in this case it is. So 2x, writing 16 in a base of 2, this is going to be 2 raised to the power of 4. Now, because the bases are same, we can equate the exponents. Now, x will therefore equal 4. Now, putting back this, let's assume this to be equation 1. If we insert 4, x equals 4, right here, we'll see that the equation is homogeneous, hence we've solved it. Now, tip number 2. What if you don't have it in a way you can write it in the same basis? Take for instance 5 exponent x is equals to 20. Now, what you will do here is take the logarithm of both sides. So I'm going to say take the log of both sides. Now, taking the logarithm of both sides, we're going to have log 5 raised to the power of x equals log 20. Now, I'm taking this to the log of base 10 for ease. Now, from the laws of logarithm, if you have log of a raised to the power of n is same as n log a. Now, let's apply this rule over here. So this is going to be x log 5 is equals to log 20. Now, divide both sides by log 5, and we're going to have x is going to be log 20 over log 5. Now, punching this into my calculator, I have x to approximately equal 1.86. This is in 2 decimal places. Now, moving on, there are some example questions to help us further solidify our knowledge. And before we go on, I will advise, if you haven't gotten your pen, paper or jotter, whatever writing material you find best, please do, and engage in the solving process. Before I solve each question, please feel free to pause the video, attempt it for yourself, and play it back once you're done. Let's continue. So, examples. Our first example, we have x raised to the power of 1/2 equals 2. Now we know x raised to the power of 1/2 is same as square root of x, and this is equals to 2. Now you can take square of both sides. Taking the square of both sides, we have x is equals to 4. Similarly, we could have taken the square of both sides here, and this 2 here, multiply the exponent in here, and it will cancel out to be x to the power of 1. Whichever way works best for you, just understand process. We move on to our next question. A to the index of -2 is equals to 9. Now please, if a lot of these concepts seem strange to you, it's probably because you haven't gotten a good grasp on fundamentals. So if you're finding this difficult, please feel free to look down in the link in the description below and watch the introductory videos I have made. They cover an extensive tutorial of the laws needed and tools that will help you as in this video. So number 2. Now from our previous video, we know if the base is raised to a negative exponent, we take the inverse of the base. Now taking the inverse of the base, this is going to be 1 over e raised to the power of 2. Then this is equals to 9. Now we can take the reciprocal, that is inverse of both sides. Now this is going to be taking the inverse, a squared is equals to 1 over 9. Now we can take the square root of both sides. Taking the square root of both sides, 1 over 9 is going to have two values, positive or negative value. Therefore, a square root of 1 over 9 is going to be plus or negative 1 over 3. There's a plus or negative because positive 1 over 3 squared is 1 over 9. Similarly, negative 1 over 3 all square is 1 over 9. So there are two possible values for this solution. Another route that can be taken in solving this is this. You want to express 9 as a base raised to an index if it can. So this is 3 squared. Now what I can do is take both sides to the index of 1/2. This is what I mean. This is going to be a raised to the power of -2 raised to the power of 1/2 is equals to a 3 squared raised to the power of 1/2. Now this is going to give me a raised to the power of -1 is equals to 3, because this is going to distribute in here and it's going to be 2 times 1/2, and the index will be 1. Now this is going to be 1 over a is equals to 3, hence a is going to equal to 1 over 3. Now observe this method is valid, but the answers are not exactly same. Now why is this? Here we took a square root which takes in account the positive and negative possible values of the root, while here this is just considering just the positive value of the root. So in a standard sense, this is a complete solution. So this is the recommended method if it's for a test on exam, I recommend you to use this because this captures the complete solutions for the equation. Now, moving on to the next question. Number 3, we have x to the index of negative 1/2 equals 5. Now, we have a negative index, so we take the inverse. So this is going to be 1 over x to the power of half is equals to 5. Now we can make x to the 1/2 power to be same as 1 over square root of x is equals to 5. Now we take the square of both sides, and this is going to be 1 over x, because the square is going to cancel the square root here, and this is going to be equal to 25. Similarly, if we had taken the square here also, the index here will multiply with the index here. It will distribute, so this will be same as saying 1 square over x to the 1/2 square, so it's more of a distributive. Then this will simplify to 1 over the index 1/2 and 2 here will multiply, leaving 1. Now this, I'm doing all this to help you understand it's not cram work, but there's logic behind what is going on here. You can go through various routes and arrive at the same answer as long as you follow the principles. Now, taking the reciprocal here, we have x is going to equal to 1 over 25, and this is our answer for this question. Now, question 4, we have n to the negative index of 2/3 2 over 3 equals 9. Again, please feel free to pause the video and attempt it for yourself. Negative index, so we're going to take the reciprocal of this. Now this is going to be 1 over n raised to the power of 2 over 3, and this is equals to 9. Now, from the law of indices, we can express this as the cube root of n all squared. Again, please, if you're finding this difficult, watch the previous videos before this, because all this has been covered there. Now, simplifying this is going to be 1 over n, cube root of n all squared, and it's going to equal 9. Now there's a square here. This is what is squared, and we can take the square root of both sides. Taking the square root of both sides, we have it to be 1 over cube root of n. Square root of 9 is 3. Now this n to the cube root of n is same as 1 over n to the 1/3 power, and this is equals 3. Now we can rewrite this as n to the negative 1 over 3 is equals to 3. Now we can take the cube of both sides. taking the cube of both sides, we have n. The index here is going to multiply this, so it's going to be negative 1 over 3 times 3. So this is going to be n raised to the power of negative 1 is equals to 27. Now 1 over n is equals to 27. Take the reciprocal of both sides, therefore n is equals to 1 over 27. My apologies. Bear in mind we took the square root right over here, so there's supposed to be plus or minus here, plus or minus, plus or minus, so also plus or minus, a plus or minus, a plus or minus, so n is equals to plus or negative 1 over 27, and this is our final answer. Now moving on to our next question, question 5. We have an interesting problem here. So 5x is equals to 40x to the index of negative half. Now right here we can divide both sides by 5, and this is going to leave x is equals to 8x to the index of negative half. So also we can divide both sides by x, or we can divide both sides by x to the index of negative half. Whichever way will give the same result. Now I'm going to divide both sides by x, and simplifying this, on this side, the left hand side I have 1, and on the right hand side I have 8x to the negative half. Now applying the division rule law of indices, this is going to be negative half minus 1, because this x right here is raised to the power of 1. Now 1 is going to equal to x. Simplifying this right over here, I have it to be negative 3 over 2. Sorry. X to negative 3 over 2. I can divide both sides by 8 here also to isolate x. So this is going to be 1 over 8 is equals to negative x to the power of negative 3 over 2. Now after isolating x, I want my x to the power of negative 3 over 2 to be on the left hand side, so I can simply rewrite this as x to the index of negative 3 over 2 is equals to 1 over 8. Now from our law of indices, I know this negative index power is going to be 1 over x to the power of 3 over 2, and this is going to equal 1 over 8. So also from the law of indices, this can be written as 1 over x, that's square root of x to the third power, and is equals to 1 over 8. Now I'm going to take the cube root of both sides to get rid of this right here. So taking cube root of both sides, I have 1 over square root of x. Now the cube root is same as saying 1 over 3 to the index of 1 over 3, and is going to equal to the cube root of 1 over 8 is 1 over 2, plus 1 over 2 cubed is 1 over 8. Now this is going to multiply this, and I'm going to have 1 over square root of x is equals to 1 over 2. Now I'll take the square of both sides, and I have 1 over x. The square here will cancel. We'll take care of the square root there. Is equals 1 over 4. Now taking the reciprocal of both sides, I have x to equal 4. Now this is a solution to our problem. Now to confirm if this is correct, I can simply substitute it back to the original question. So 5 into bracket 4 equals 40. Substituting 4 in place of x, reciprocal of negative 1 over 2. Now this is 20 on the left hand side. On the right hand side, I have 40 times 1 over 4 to the half power. Now this 4 to the half power, it simply means I'm taking the square root of 4. So this is 20 equals 40 times 1 over square root of 4 is 2. So 20 equals 20. Now my left hand side equals my right hand side, so I know I am correct. Now I know this may seem like a lot, but just take your time. If you need to replay, please do. But right now I'm going to show a shorter method that you can use and it will still give you the same result. Now coming back all the way here, from this part, I can just say take both sides to the index of negative 2 over 3. I choose negative 2 over 3 because I'm trying to think of how I can get rid of this negative 3 over 2 and make it an index of 1. So what I need to multiply negative 3 over 2 is negative 2 over 3, and that's why I choose negative 2 as 3 over 3. Now doing that is going to be x negative 3 over 2 to the index of negative 2 over 3, and is equals to 1 over 8 to the index of negative 2 over 3. Now this is going to multiply this and leave it an index of 1, so x to the index of 1 is equals to 1 over 8 to the index of negative 2 over 3. Or simply, since we know from a law of indices, when you have an exponent that is negative, a negative exponent, you take the inverse of the base, which the base in this case is 1 over 8. So that is going to be 8 to the exponent of 2 over 3. Now x is going to equal to, now this is same as saying cube root of x all squared. Now x is equal cube root of x of 8 is 2. Now square of 2 is 4, so x is equal to 4. So this is another way you can solve this quicker and faster. Please let me know which one you prefer best. Now moving on to the next question. We have 9 raised to the power of x equals 27. Please pause the video and attempt this for yourself. So expressing this in its lowest base, we have 3 square raised to the power of x, and this is equals to 3 cubed. Now this can multiply the index here, which is 2, so we're going to have 3 raised to the power of 2x equals 3 raised to the power of 3. Now remember, anytime you have same bases, we can equate their indices. So 2x is going to equal to 3. Therefore, x is going to equal 3 over 2. Simplifying this, we have 1 whole number 1 over 2. And this is the solution to that. Now let's take it a step further. This is the given equation. 4 raised to the power of c minus 1 is equals to 64. Now, as usual, 4 to the power of c minus 1 is equals to 64 can be written as 4 raised to the power of 3. Now, I have the same base, so I can equate the power. So c minus 1 is equals to 3. So c, adding 1 to both sides, c is equals to 4. And this is my solution to this question. Again, if you want to confirm your answer, you just plug value of c back into the original equation, and 4 minus 1 is 3. So the left hand side equals the right hand side, so I know this is correct. Again, if you want to, you could have expressed it to the lowest base, which is 2 to the power of 2 c minus 1 equals 2 to the power of 6, because 2 to the power of 6 is 64. Now, again, equating the base, 2 in open bracket c minus 1 close bracket equals 6. This will distribute here and here, so this is 2c minus 2 equals 6. 2c is equals to, add 2 to both sides, 8. So now dividing both sides by 2, I have c equals 4. So this is another way, a longer way to solve it. Now, I want to begin a slightly more advanced chapter of this. Now, if you're wondering, can it get any harder than this? Well, it depends on your definition of hard. Once you understand the basic concepts, the laws, and you apply them, I promise you, once you take it step by step, you realize it's easier than it appears. Now let's take this example. 5 raised to the power of 2x minus 26, open bracket, 5 raised to the power of x plus 25 equals 0. Now, if you're asked to solve this, what do you do? Now, the first thing you want to do is simplify this such that you have 5x. Now take this all squared. This is same as this, because when you multiply the exponents, you still have 5 to the power of 2x. Now minus 26, 5 to the power of x plus 25 equals 0. Now I did this so I can easily say I'm going to choose an alphabet to replace 5 to the power of x with. So I'm going to choose p. Let p equals 5 raised to the power of x. Now, substituting 5 raised to the power of x with p, I have p squared minus 26 p plus 25 equals 0. And now looking at this, you can quickly notice we have a quadratic equation right here. Now this makes solving it way much easier. Now solving this, two factors, we need to find two factors that will multiply to give 25 and can add up to give negative 26. Now this is what I mean. What are possible numbers that we can multiply to give 25? So I have positive 5 and positive 5. It will give me positive 25. I have positive 25. I also have positive 1. It will multiply to give me 25. I have negative 25 times negative 1. It will multiply and also give me negative 25. Now, among this, which of these pairs will add up to give me negative 26? Now, what can add up to give me negative 26 among these pairs is this. So, the two numbers I'm going to use are negative 25 and negative 1, because they'll multiply to give positive 25 and add up to give negative 26. Now, these two numbers that will add up to give negative 26, I'm going to put them in place of 26p. Now, this is what I'll have: p squared minus 25p minus 1p. Now, observe negative 25p minus 1p is still negative 26. So, we're just transforming this equation here. I just transform this equation. Then, plus 25 equals 0. Now we factorize p squared. From this we can factorize p. So factorizing p, you have p minus 25, because when we distribute this, we have p squared, and distribute it here, we have 25p. So again, what we're doing is just transformation of the equations. Now we are left with this. So I know this is factorizable. It's not like it's something I need to use the quadratic equation. So my goal is to make whatever is going to be in this bracket to be same as this. So what I can do to make that happen is factor negative 1. So factoring negative 1, I have p minus 25 over here, and it's equals to 0. Now I can also, what I'm going to do now also is factor p minus 25, because it's appearing here and it's also appearing here. So factorizing p minus 25, I'm going to be left with, if I factorize p minus 25 from here, I'm left with p, and when I factorize p minus 25 from here, I'm left with minus 1, negative 1. So my two roots are p minus 25 and p minus 1, and this is equals to 0. Therefore, p minus 25 is equals to 0, or p minus 1 equals 0. Now you're asking, why may this be? If I have two numbers, they can equal 0 only if one of them is 0. So this is 0 either when I have 5 times 0 is 0. Any number multiplied by 0 is 0. So if I have a number and it's equal 0, either one of the number is 0 being multiplied is 0, or both of the numbers being multiplied as 0. That's when they can equal 0. So my goal is to find which of the numbers as equivalent to 0. So that can happen when p, taking this to be equation 1 and this to be equation 2. So from equation 1, p minus 25 can equal 0 only when p is equals 25. Hence we have 25 minus 25, which will equal 0. From equation 2, also I have p minus 1 equals 0. That can only equal 0 when p is equals to 1, because 1 minus 1 will be 0. So this is from equation 2. Therefore, I have p is equals 25 or p equals 1. Now, remember earlier on we said let's 5x equal p. Now I need you to recollect that back because we are going to use it here. So now I'm going to put back 5 raised to the power of x in place of p. So 5 raised to the power of x is going to equal to 25, or 5 raised to the power of x equals 1. Now, taking to the common basis, we have 5 to the power of x is equal to 5 squared, or 5x. There's no way you can express this one here to the base of 5, so let's leave it as 1. Now, equating the exponents from this side, we have x equals 2. Now, coming here, we remember from our law of indices, a base raised to the power of 0, that's anything raised to the power of 0 is 1. So the only way this can occur is when x is equals to 0. Therefore, x is equals to 2 or x equals 0. This is a solution for this example. Now, let's take one more. This will be the final example for today. Then I'm going to leave one exercise question. So b 5 to the power exponent of 2x plus 1 minus 26 5 to the power of x plus 5 equals 0. Now, again, once you try and transform this in such a way, the equation appears simpler. Now, the law of indices I want you to recall here is the multiplication law. If you have e raised to the power of n times e raised to the power of m, this is going to be e raised to the power of n plus m. Now, over here, we can see a similar pattern. Now, breaking this down, I have 5 to the power of 2x times 5 to the power of 1. I'm going to put this in a parenthesis. Minus 26 5 to the power of x plus 5 equals 0. Now, I'm going to factor out the 5 that is here. So this is going to be 5 to the power of 2x minus 26 5 to the power of x plus 5 equals 0. Now this is looking far much simpler than the original question given. Now this, we can break it down as we did in A, and after breaking this down, we are going to have 5 raised to the power of x squared. So this is going to simplify to this 5 open bracket 5 to the power of x squared minus 26 5 to the power of x plus 5 equals 0. Now, again, I'm going to choose any alphabet to equal to 5 to the power of x. The alphabet I'm choosing is P, equal 5 to the power of x. So this is going to be 5p square, putting p in place of this and p in place of this, then minus 26p plus 5 equals 0. Now I'm going to check, is this factorizable? Then I can use factorization method of solving quadratic equation. If it isn't, I'll use quadratic equation. Now this is factorizable, so what I'm going to do here is factorize this. So to factorize an equation like this, since the coefficient of p square is not 1, I'm going to multiply the coefficient of p square and use it to multiply this. So this is what I mean. 5 times 5 is 25. So now this is going to be the reference term I'm working with, kind of how we had in the original example, p square minus 26p plus 5 equals 0, then plus 25 equals 0. Then we're looking for two numbers that we could multiply to give 25 and add to give negative 26. Now in this case, this is going to be my reference term. So the 25 here is serving the same role as 25 here. So this is my role player. And to get this role player in an equation like this, I need to multiply whatever the coefficient of p square is here by the n term here. Now take in note the general equation or general form of the quadratic equation is ax squared plus bx plus c. So I'm going to multiply the coefficient of x squared, in this case, which is a, by c, and I'm going to use ca. I'm going to find two terms that I want to multiply to give me ca and add up to give me b. So I use a different scenario to help you grasp the concept of what I'm saying. Now again, two terms can multiply to give 25, positive 25, and add to give negative 26 are negative 1 and negative 25. So 5p square, now negative 25p minus 1p plus 5 equals 0. Now this negative 25p minus 1p is still negative 26. So this and this you can see are still homogeneous, but we've done it in such a way that it's easily factorizable, and you can do this for equations of this form that are factorizable by following the method I just explained. Now factorizing this side, we can factorize 5p, for 5 and p are common factors on this side. So 5p, open bracket, 5p minus 5. Here also, remember, I want to make sure that whatever is in here is same as whatever is in this bracket. So what I can do or factorize out of this is negative 1, and this is going to give p minus 5. When I distribute this here, I have negative p. I distribute this here also. Negative 1 times negative 5 is positive 5. So you can see they are same. Again, transformations. Now I can factorize p minus 5 because it's common here and it's also common here. So factorizing p minus 5, this is going to leave 5p. If I factorize p minus 5 from here, I have 5p left, and when I factorize p minus 5 from here, I have minus 1 left, and it's equals to 0. So from here I have p to equal 5, or p to equal 1 over 5 when I solve this. Now remember, earlier on we said p to equal 5x. Therefore 5x equals 5, or 5x equals 1 over 5. Now the bases here are same, so we equate the exponents, so x is equals to 1. Now on this side, I can transform this to be, this 1 over 5 is same as 5 to the power of negative 1, equating exponent x equals negative 1. So these are the solutions to this equation. Now the exercise question that I'm giving, the 2x plus 2x plus 1 minus 8 equals 0. Sorry, there's a 2 here. And I'm going to give the answers so you know if you're correct or not. So the answer here is just 1. X equals 1. Now this is answer. This just has one answer, and the hint I'm giving here is this can be written as 2 raised to the power of x times 2, as explained earlier. Now this is an assignment, but I understand you may want a reference solution when you're done. So this no doubt is an assignment, so please pause the video and attempt the question with the hints provided, but I'm also going to solve it here. So this is going to be 2x to the power of 2 plus 2 to the power of x multiplied by 2 minus 8 equals 0. Now let's p equals 2 raised to the power of x. Then this is going to be p squared plus 2p minus 8 equals 0. Now factorizing this, two numbers I can multiply to give negative 8, and I can add to give positive 2p will be positive 4 and negative 2. Positive 4 times negative 2 will give me negative 8, and positive 4p minus 2p will give me 2p here. Now this will be 2p, this will be p squared plus 4p minus 2p minus 8 equals 0. Factorizing, I can factorize p because it is common on that side. This is going to be open bracket p plus 4. I can factorize negative 2 from here, and I have p plus 4 also, and it equals to 0. Factorizing p plus 4, I have p minus 2 in parentheses. Let me slow down a bit. So factorizing p plus 4 on this side, I have p. Factorizing p plus 4 on this side, I have negative 2. And this is all equal to 0. Solving this, I have p equals negative 4, or p equals 2. Now remember, we said p is equals 2 to the power of x. Yes, so 2 to the power of x is equals to negative 4, or 2 to the power of x is equals 2. Now on this side, we can see there's no way we can express this that the base will be same. Now someone may say I can express this as negative 2 square, but the bases are not going to be the same. Our focus, the only way you can equate the exponent is when the bases are same. Now, if I have negative open bracket 2 square, there's no way it's same as the base here, which is just 2. So for this part, there is no solution. So yes, it's possible to have equations that have no solutions, and this is an example of one of those cases. But on this side, we can see bases are same, so equating the exponent x equals 1, and this is our answer to this solution. I hope you've enjoyed the video thus far. Please subscribe to stay updated, and let me have a view of your opinion in the comment section. Have a nice day.